Okay, Assalamualaikum and good day everyone. So let's continue our lecture with the example of the mechanical system where we have two mass system. In this case, this is a dynamic example, dynamic absorber, for example. Okay, you can see from these lecture slides here, we have two mass here. We have M1, and then the M is applied by the force of F that push the M to translate into X motion, whereas for the M1 it has translational motion of X1. Okay, for this mechanical system, we have to come up with two equations because we have 2 degrees of freedom where we have two mass M and M1. So let's focus on the first one first. We have mass M. Okay, for this case, let's consider the components that connected to M1. So to the mass M. So this is the mass M. So the component that connected to this mass is K, and then we have K1 and we have C1. Okay, so we write the equation where we have for this one is Ft is applied on the mass M, and then we have the motion due to M, so we have mx double dot, and then we have plus we have C1, so we have C1 x dot, and then we have the spring, we have plus K plus K1 x. Okay, and then we need to consider the motion that is due to the M1. So in this case, we have K1 and C1. So minus, in this case, we have C1 x1 dot minus K1 x1. Okay, all right. So we have finished to come up with equation for the mass M. Now let's consider mass M1. Okay, for the mass M1, so let me erase this first. So right, so for mass M1, so let's look at what are the components that is connected to mass M1. So now we have only two components, which is K1 and C1 over here. So we can have this, so there is no such thing as force that is applied on the M1. So we have 0 equals to, so we have M1 x1 double dot plus, so we have damper C1 x1 dot, and then we have K, which is K1 x1 over here, and then we need to consider the motion that is due to mass M. So in this case, we have K1 and C1. Okay, so we minus, so we have the damper C1 x dot minus K1 x. Okay, so we already have come up with two equations here. So the first one and the second one. So this is the first, this is the second one. All right. So what's next? The next thing to do is to transform this equation into the Laplace domain. So we rearrange and we come up with these equations. Okay, we have equation 3 and we have equation 4 over here. So to draw the SFG, so remember, we now have 3 parameters. So we have x, we have x1, and we have f. So our input is actually, so input is given by fs. So our output, so based on this diagram here, so our output is actually x1. So we want to find a x1 over f. So this is our so this is output. Output here is actually x1. Sorry. So we have x1. So basically, these things is not coming out on my screen. So let me erase first. Okay. So we have input fs, and we have output is x1s. Okay, and then we have other parameter which is xs. Okay, so now in order to draw the SFG, we need to have equation x s equals to something and x1s equal to something. Okay, so that's why we rearrange the equation, equation 3 and equation 4 to this equation. So we have equation 5 here, and then we have equation 6 over here. Okay, so from equation 5 and equation 6, we can draw the SFG over here. So the SFG, we have the first one, we need to put the input at the front. We have to put input f, and then we need to come up with a x over here, and then the final one is the we have the x1 as the output. So you draw the relationship between x and x1 to the f. Okay, so based on this equation, x1 is contributed by x, and then we have the x1 is contributed by x over here, and then we have the x1 also contributed by f. So that's why we have this line over here. And finally, from equation 6, we know that x is contributed by x1. So that's why we have this arrow here from x to from x1 to x. Okay. Next. So we can use the Mason-Gain formula to find the transfer function of x1 over f here. So we have t1, so we can come up with t1. Our t1 is actually this path, so we have t1, and then we have our delta 1 equals to 1. Okay, so delta 1 equals to 1 because there is no loop that do not touch the forward path. And then our delta is actually 1 minus a loop, so we have only one loop here, so this is the loop over here. So that's why we have this kind of equation. This is the delta actually. Okay, this is the delta. Okay, and then we can rearrange the fraction over here, and we can simplify so that we can get this term for x1 over f. So you can try this to how to come up from this fraction to this fraction. So it is actually pretty simple. We can also find the transfer function if, let's say, I ask you to find x over f. So it is also possible to find the transfer function x over f using the same signal flow graph. So instead of having t1, this one, so our t1 now, if x, so this is the ending here, we want to have the ending at here, so our t1 is actually continue to this point. Okay, so that's why our t1 now is actually is multiplication of this and this. So that's why you have this multiplied by this, so you have this term over here. Okay, and delta is actually the same for the previous transfer function. So using the same signal flow graph, we can get the delta is the same. Delta is the same. Here and here is actually the same. Okay, so the difference is only between here T1 and T1 of this. T1 of this is not the same as T1 of this. Okay. Okay. And then we can simplify the fraction from this to the final term of x over f over here. So you can try to find how I get from this point to this point. Okay, so please try it at home. Next one, we have this example here. We have a 3 degree of freedom. So we have M1, we have M2, and we have M3. So I give you the hint to find the equation. So we need to find 3 equations, and we have mass 1, mass 2, and mass 3. So this is how you find the equation, where you can find each one sum of impedances that is connected to the motion. X1, X2, and X3, and also you can consider the forces, sum of forces that apply at the X1, X2, and X3. So I give you the equation for M1, M2, M3. So I need you to go back. You're already at home. So I need you to find the equation for M1, M2, M3 here. Please practice because when you do a lot of practice, then you can shorten the time to analyze the problems that have been given to you. Okay. Alright, so I think this is the end for the translational modeling of the mechanical system. So next we will proceed with the new topics of rotational modeling of rotational mechanical system. Okay, until then, see you in the next video.